Fundamental Theorem of Calculus, section 4.6, talks about how many conjugate solutions there are to a polynomial. And now, again, we're working with a complex number system. And that basically says is that there are n number of complex solutions, and n refers to the degree of the polynomial. So for example, if the degree is 1, it has one solution. 2, there are two solutions. 3, notice that there are imaginary solutions, but there are still going to be 3 solutions. And so this is a big theorem, and so some questions are very easy, like this one. How many complex solutions are there? There would be 3, 4, because you're basically looking at that degree. But this question becomes quite long when you're supposed to find the zeros. Now, we had this before, but now I know if I'm working in the complex number system, I have to come up with 5 solutions. So what I would do is I would start testing numbers. And when I do that, I'm looking at 1, putting in 1. Again, I'm just going to write these numbers down quickly. You know that doesn't work. It doesn't equal 0. Putting in -1. And you'll see that you get, I like adding the negative ones and comparing it to the positive one, and you get 12 is 12, so it's 0. So -1 does work. So now what I want to do is use synthetic division on -1. And again, I'm going to remember to put my 0 down because there isn't a x to the 4th term. And this is going to be a long problem. There's no way around it. And so again, multiplying the numbers and adding down. And you should always get this to be 0 if you did it correctly. Now, these are the coefficients of the next polynomial. So it would be x plus 1 times this polynomial would give you this polynomial. So let's see, this be x term, x squared, x to the 3rd, x to the 4th, x to the 4th, x third, and now the question is, well, what are going to be the x's such that it produces 0, and then I can do this whole process again. Now I tried 1 and -1, so I'm going to start with 2 on this one and try to -2 if I need to. By putting in 2, I get 16, -8, 8, -8, -8. Those cancel and those add up to -16, so that does work. Now, again, synthetic division. So we're repeating this process, and I'm looking at the coefficients, repeating the process twice to see where it's going to lead me. And slowly but slowly, I'm going to get these solutions as I go through. All right, bringing it down and multiplying. And you again would get 0 as your remainder. Now, this is a gift because I know that these coefficients, I can see the ratios are going to be the same, which tells you that I can actually factor by grouping, which you normally wouldn't get excited about factoring, but in this case, I would get more excited than the regular case. So this is going to be factoring out an x squared and now a 4. And I'm going to see that that's equal to 0. And now I can see that x squared plus 4 times x plus 1 equals 0. Now, that's going to tell me basically all of my answers. I'm going to see that x equals -1. I'm also going to see that x squared equals -4, or x equals the square root plus or minus -4, x equals plus or minus 2i. Now the question, way back when, is find all zeros. Okay, -2, -1, -1, 2. So it's going to be x equals -1, 2. Here's another -1, so that's actually a double solution. And then it's going to be -2i and +2i. So there's 1, 2, 3, 4, 5 solutions, which is what the fundamental theorem of algebra is saying.